Hello everyone. So my name is Dr. Karthikeya. So I am from Abhyas EduTech IIT preparation team. Today, especially in this video, we are going to discuss about system of particles, rotation motion, JEE Mains 2024 questions. So for solving these problems, we need to understand what is meant by center of mass, where it is situated for different bodies, and what is position vector. So this has to be known, especially related to system of particles, center of mass concept. So after that, we are going to rotational motion problems, where we need to understand, so especially what is angular displacement, angular velocity, angular acceleration, torque, moment of inertia, angular momentum, what is conservation of angular momentum, what is angular impulse. These concepts should be known. What is the relationship between linear displacement, linear velocity, force, linear acceleration, force, mass, and linear momentum, and also impulse. So this should be known, and the relationship between them also should be known in a proper way. Okay. So now going to the first question. So first question. You see two identical spheres, each of mass 2m, are placed at the corners of right-angled triangle with mutually perpendicular axis. Sides each of side 4 meters. Taking point of intersection of these two sides as origin. Magnitude of position vector of center of mass of the system is 4 by root 2 x, where the value of x is. So it's a numerical question. So if you observe here, right-angled triangle is like this, where origin is this one, 0, 0, and so two identical spheres are 2m with placed at the corners of right angle with mutually perpendicular side. So then each side is 4 meters. Okay. Next, taking point of intersection of two sides as origin. So here two sides are there. So magnitude of position vector of center of mass of system is this one. So if you observe, so R com is equal to M1 R1 plus M2 R2 plus M3 R3. Here M3 is not there. The identical spheres, each of mass 2m, are placed at the corners. Okay. So here total mass M1 plus M2 plus M3. Here, if you observe, what is here? 4, 0. This is 0, 4. Okay, you can take. Now, what happened? This is 4i cap. This is 4j cap. 0i plus 4j cap. 0i, 0i. So, now if you take this one, 2m into 0i plus 0j plus 2m into next 4i plus 2m into 4j by 6m. So now 8i plus 8j by 6m. Okay. 6m. Okay. Here now m is there. Cancel. Okay. Now what happened? Magnitude. So this is 4 by 3. Okay. If you see 8 by 6 means 4 by 3 into magnitude of I plus j. Okay, that is 4 by 3 into root 2. So what is the value of x? X is equal to 3. So this is the answer. So simple only. You have to understand what is center of mass, what is position vector. So R com equal to individual masses are there. So that sum that multiplied with masses by total mass. Okay, now going to the next one. Here, this is another problem where thin metal plate is there. Here, mass of the metal plate is 10 kgs. Ratio of coordinates of center of mass is n by 9. Here, this problem can be done in many ways. I am going to deal in a simple way. You observe here. Here, so I am just taking this one into 3 things. This is 1. This is 2, this is 3. Here, I am considering area mass density, that is mass is equal to, or sigma is equal to m by a. Sigma is equal to m by a. M is equal to sigma into a. First one you consider, this is m1, this is m2, this is m3. m1 is equal to sigma into what is the area? Here length is 3, height is 1, that means 3. So that is the sigma into 3. Similarly, m2 is the second one, sigma into what is the area? Here from 0 to 1, 1 into 1, that is 1 only. m3 is equal to area. See this is what? 2 comma 2, 3 comma 2. Here 2 comma 1, 2 comma 1 into 1. Here also 1 into 1. This is 3 into 1. So this is also sigma into 1. Okay. Now again same. X com is equal to, x com is center of mass of the x coordinate of center of mass, that is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Okay. Similarly, y center of mass is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Okay, now if you observe, what is the center of mass? X1 for this one, 3 by 2 means 1.5 comma, so this is 1, that means 0.5. Okay, for this, what is this? Always you observe from this only. Okay, 0, here 1. What is this? 0.5 comma, what is this? 1.5. Here also 2 comma 1. This is what? 1 comma, okay, 1 comma 2. 1 comma 2, 1. That means 1.5. Okay, sorry. This is 2.5. What is this place? 1.5. Okay, 2.5 comma 1.5. Up to this 2. In between it is there, that is 2.5. Up to this is what? 1 top. Middle will be here 1.5. Y will be here 1. Okay, plus 0.5. 1.5, 1. Here 0 plus, this is 1. 0.5. Okay. Now you substitute here, x com is equal to what is m1? Sigma, 3 sigma into x1 is how much? 1.5 plus sigma into x2 is how much? 0.5 plus sigma into, that means m3 is sigma into 1, 2.5. 2.5 by 3 sigma plus sigma plus sigma. So 1.5 into 4.5, sigma I am taking common, by 5 sigma plus 0.5 plus 2.5, that is how much? 7.5 by 5 sigma. Okay, I'll write. Next one, y com is equal to 3 sigma into 0.5 plus m2 is sigma into, this is what, 1.5 plus sigma into, what is this, 1.5 by 5 sigma. So 3 into 0.5, that is 1.5 plus 1.5 plus 1.5 by 5 sigma. Sigma you can take common. So that is 4.5 by 5. This is what? 4.5 by 5. This is also sigma cancelled, 7.5 by 5. Now x by y, how much? X by y is equal to 7.5 by 4.5. That is equal to n by 9. 2 cancelled, n equal to 15. So this is the answer. So n value is 15. So this problem we can do in many ways by taking full portion. From that you can subtract this one, this small portion. That is one method. Another method is taking individual portions and calculating the x coordinate, y coordinate for the entire body, entire thing. So we are splitting into 3 pieces, each individual part. We are calculating x1, y1. That means for that part, what is x1, y1, center of mass. For this, after that, for entire thing. x1, y1, x2, y2, x3, y3. We are just calculating using the formula n equal to 15. Simple. Now going to the next one. Here, what is asking in a system? Now motion of center of mass means change in the position of center of mass means moving. The body is moving. Previous thing is stationary. Okay. Here it's moving. Okay. Now you observe here M1 in a system of two particles placed at certain distance from each other. Particle M1 moving. M1 is moving. M1 is moving. How much it moved? 2 centimeters. Okay, x delta x com is equal to m1 into delta x1 plus m2 into delta x2 by m1 plus m2. But here what happened? X com is not varying to keep the place. It should be to keep the original position only. X com delta x com is 0. It's not moving. So 0 is equal to, I'll erase this. Okay, delta x com is equal to m1 delta x1 plus m2 delta x2 by m1 plus m2. Here delta x com is 0. 0 is equal to 3 into 2 centimeters it moved. 2 centimeters it moved. 2 centimeters moved. So next m2 is 2 centimeters. Delta x2 you have to find by 3 plus 2. But what we will get? 3 into 2, 6 is equal to 2 minus 2 into delta x. Delta x equal to 3 centimeters negative. That means it is moving this side, means that should move this side. So okay now 3 centimeters. This is the answer. Now going to the next one. So in order to keep the entire system of particles, that is entire center of mass of the two bodies, there are in the system there are two bodies. One body is moving this way, another body should move in other direction. So that entire system of mass, entire system center of mass should be proper. Okay. Now another one. Here, if you observe here, 1000 kg mass is moving horizontally like this. We are adding 2000, then final velocity. In the system, there is no force. That means initial momentum is equal to final momentum. So 1000 kgs into 6 is equal to 1200 by 1000 plus 200, 1200 into V2. So 5, this is 6. So V2 is equal to 5 meter per second. Simple one. M1 V1 equal to M2 V2. But the direction is opposite. Okay. So this is the simple question. So these are about center of mass problems. Now going to the rotation motion. Here, if you observe, first thing, moment of inertia resembles mass in linear. So what is the significance of mass in linear velocity, linear type of motion? Same thing will be there for the moment of inertia. Here you observe there are four sides for a square. 4 particles are there. 4 corners are there. 4 particles, each of mass 1 kg is there. So here one, here one, here one, here one. This is A. Okay, each side is A is 2 meters. Okay, A is 2 meters. Now, if you see moment of inertia, I total is equal to, for the total means for this vertex, what is we are calculating? M, this is M, right? M into A square. So moment of inertia formula, mass into mr square. Okay, r is the distance between axis and the particle. First one. Similarly, for this mass, if you consider this as A, B, C, D. A to B, ma square. Similarly, A to D also m into A square. Plus, for C, it is diagonal. What is the distance? Root 2 A. So, m into root 2 A for that square. So, now ma square, ma square, ma square. That is 4m A square. 4 into M is 1, A is how much? 2. So 4 into 2 square. 2 square is 4, that is 16 kg meter square. So this is the answer. Simple question, no need to worry. So these are very simple questions. Two identical spheres, each of mass 2 kgs are there, and a radius. So this is mass 2 kg. This is also mass 2 kg. Radius of the sphere is r is equal to 50 into 10 power minus 2 meters. For this also radius equal to r 50 into 10 power minus 2 meters. Then the separation between them is 150 centimeters. 150 centimeters. This is the separation. Okay, 150 centimeters. 150 into 10 power of minus 2. So moment of inertia about an axis perpendicular to the rod. Somewhere in between it is there, that is perpendicular. So that is exactly middle. 75 into 10 power minus 2. If you consider from the axis, if you consider for one thing, you can do the other thing. So actually for the sphere moment of inertia is 2 by 4 mr square plus m into this distance, md square. Okay. For one mass it is this, but how many mass are there? 2. That's why I is equal to this one. 2 by 5 m into 2 into 50 into 10 power minus 2. For that square is there, plus m another way 2 into distance is 75 into 10 power minus 2. For that square is there, into 2. You just calculate. Okay, now you can calculate this one. 4 by 5 into 50 into 10 power minus 2 means, so 50 by 100, that is 1 by 2, 1 by 4. Okay, 50 by 100, right? 1 by 2, 1 by 2 for that square is 1 by 4. So you can write like this, plus 2 into 75 by 3, 3 by 4 square into 2. Okay, so you can do simply like this, 1 by 5 plus 1 by 5 plus 2 into 9 by 16, 18 by 60 into 2. Okay, you just take care of this. I'll write here 16 plus 40 by 16 5 is how much? 80 into 2. Okay, 2 get cancelled, 40. So that is 56 by 40. That means 28 by 20. That is, if you equate to x by 20, x equal to 28. So like this you have to calculate. Just check that. Okay, 2 by 5 mr square. 2 is there. 50 by 100, that is 1 by 2. That's why I have written 1 by 4. Okay, 4 by 5 right. 1 by 4 written. 2 into 3 by 4, 9 by 16, 9 to 18, 18 by 60. So into 2 is there because 2 masses are there. So if you take LCM, 16 5 is 80. If you write like that, 16 plus 18 5 is how much? 90. 90 plus 16, how much? 116. 116, okay? 116, right? 116 means 59. Okay, I'll just change this. Okay, 116. 116 by 40. So 20. Again, after this, it will be 20. This is 5. Okay, 58. Okay, 58. So x equal to 58. It's not 28. Okay, that is a thing. So we can easily calculate this kind of problems if you know the concept, how to apply the formula. So it's not only theoretical. Physics means we need to understand the concept, and application is also very important. Okay, now see this. Another problem which is also related to moment of inertia and radius of gyration. 3 balls of masses 2 kg, 4 kg, 6 kg are respectively arranged at the center of edge of an equilateral triangle of side 2 meters. So again you can take so equilateral triangle. So 2 kg, 4 kg, this is 6 kg, each of side 2 meters. Okay, so center of mass will be at this one. So medians joining that one. So if you calculate this, R is equal to, what is the answer? So root 3 by 2 into that one you can take. So you'll get 1 by root 3. R is equal to 1 by 3 root 3, where this is situated. So if you calculate, I is equal to M1 R1 square plus M2 R2 square plus M3 R3 square. This is the point where this one is situated. So that's why I have taken R is the equilateral triangle. For equilateral triangle, everywhere, for every mass, this is the distance. This is 1 by root 3. Okay. So R1 is R1, R2, R3 are same. For that, square is there. That's why I am writing 1 by 3 directly. This is a 2 plus 4 plus 6. That is how much? 2 plus 4, 6. 6 plus 6, 12. 12 by root 3 is 4 kg meter square. So for this, you need to understand where the center of mass is located. That is exactly this point. You can clearly understand, that is R equal to 1 by root 3. So this is mathematics knowledge, you can clearly understand. So R is same for everything. That's why I have taken R square. That is 1 by root 3 square, that is 1 by 3, 2 plus 4 plus 6. So you can clearly get. Simple problems, no need to worry about the things. Hardly 1 or 2 lines. You are getting easily 4 marks. Yeah, next one. Okay, next one here. In this problem, especially uniform rod is now going to the torque and angular momentum. Torque is nothing but there are two things. Torque is equal to vector product of radius into force, or another formula is also there, that is I into alpha. I is moment of inertia, alpha is angular acceleration. So how to calculate the torque, all the things you should know before going to solve this kind of problems. So here, uniform rod mass is given, that is 2 kgs. Length of the rod, that is 30 into 10 power minus 3, that is 0.3 meters. On a smooth surface, so AB rod is there, an impulse is applied at the end. So here something like this, an impulse of force is applied to the end. So there is a rod like this, time taken by the rod to turn through at right angles. Okay, so impulse is given. So similarly we have angular impulse, that is angular impulse is equal to, so angular impulse is equal to tau dt. But a linear impulse, that is linear impulse is, okay, linear impulse is f dt. Okay, so but what happened? This is there, so this is there. So tau equal to rf, tau equal to rf. That's why I am writing linear impulse. I am writing as something like Li I am writing for your understanding, into what is the r, distance. So for rod it will be exactly at the middle. So for rod we are taking this rod such that to time taken by the rod to turn through at right angles will be, okay, here impulse is here for the rod, it is applied, AB is the rod, impulse is applied at the end B. But what we have to take for the rod, the center of mass will be exactly at the L by 2. That's why I am taking into L by 2. That means it is L by 2. At the L by 2 we are applying the torque. That's why it will rotate like this, right? So if it is like this, if you apply at the L by 2, so here it will change. Okay, now linear impulse is given, that is in the question 0.2 into L by 2 is how much they have given. L is 0.3 by 2, if you take, that is 0.03. Okay, this is what angular impulse. Okay, angular impulse is 0.03. Now what happened? Angular impulse is equal to, that is angular impulse is equal to, if there is equal to I omega. Okay, what happened? Why I taken I omega? Because initially this was at rest. That means I f minus I omega f into omega minus I omega 2 minus I omega 1. That is equal to angular impulse, that is 0.03. But what is this I? Here rod. Here rod. So for the rod, ml square by 12 into omega final. Okay, now you see what is this? M is 2 kgs, 2 into L is 0.03 for that square. L is 0.3. L is what? 0.330 for that square. Okay, I'll write like this. 0.3 whole square. For that 12 is there. Here if you cancel, this is omega f. This is 0.03. Okay, 0.03 is equal to 0.09 by 6 into omega final. 3, if you cancel, omega final is equal to 2 radians per second. What he want? Time he want. Okay, time he want. Omega initial is 0. Omega final 2 radians per second. Omega, this one. Okay, now what is this? Okay, I'll tell you. So omega final is equal to omega initial plus alpha t. Alpha t. Okay, now omega final is 2 radians is equal to 0 plus alpha into alpha value. How much? Alpha value. Okay, alpha into t, or sorry, theta. Okay, you can do in another way, that is simple way. This is alpha is not given. Okay, omega final, yeah, omega final is equal to theta by t. General formula I am using. Omega final you got 2 theta by pi by x. Okay, angle is pi by x. Okay, time taken by the rod to turn at the right angles. Right angles means what is the angle? What is the angle? Okay, pi by 2 by time t. T is equal to pi by 4. So directly you can get this. No need to go for alpha and other things. That is equal to pi by x. X is equal to 4 seconds. This is the answer. Simple only. We just have gone through many things. Whatever concept that is related to torque, angular momentum, we have gone through. This is a very good bit because you are involving more concept and trying to solve the things in a systematic way. Okay, that is about this question, which is very important. Now going to the equilibrium and the toppling. Heavy iron bar is there of weight 12 kg is having its one end on the ground, other end at the shoulder of the man. So something, man is like this, his shoulder is like this. One is at the ground, other one is at shoulder of the man. So like this it's there, shoulder of the man. Okay, like this. One other thing is at the ground. So here for any rod, weight will be acting at the middle center of gravity. That is, if the rod length is L, this will be how much? L by 2. L by 2. Okay, weight is this one will be mass of this one is L by 2. But here angle theta will be there. That angle is 60 degrees. So now how much will be acting? Weight experienced by the man, but it is experienced by the man at this place will be, what is this? Okay, if it is mg into L by 2. Okay, so here L by 2, weight into this one is equal to this tension into, okay, whatever things L. Okay, here cos theta will be there for the both the things, the angle will be there. So in both sides, so L cos theta. Okay, so but what happen if it is cancelled? What you will get? So other things will be half of this one. That means it will be 12 by 2. That is by 2. So you can get 6 kgs. So simple. For this, okay, it's very easy one only. Weight will be at the middle, but for him it won't be full. It will be half only. If you take this kind of consideration, it will be half only. So now going to the another question. So another question is also in the similar model. So here also if you observe, A heavy iron bar of weight W is having its one end at the things in the ground and other will be at the shoulder of the person. Bar makes an angle theta with horizontal. Weight experienced by the person, what is the answer? That is W by 2 only. Not full, because it will be so similar kind of problem what we told in the previous problem only. So half of the thing only he will experience, because it will be if you see the torque between that one, you can clearly get that one, W by 2. Okay, now going to the next one. Next, conservation of angular momentum. How we have conservation of linear momentum, like that only conservation of angular momentum also there. If there is no external force, so no external force means the initial momentum of the system is equal to final momentum of the system. Similarly here, if there is no torque applied on this one in the system, then initial angular momentum is equal to final angular momentum. Now if you observe here, a body of mass m is moving with a uniform speed of 3√2 meter per second along the xy plane. Okay, y is equal to x plus 4 along the line, y equal to x plus 4, that is y minus x equal minus 4 equal to 0, where if you observe angular momentum of the particle about origin he want, about the origin he want. So angular momentum generally L, it is represented as L mv into perpendicular distance. So that is also, what is this, tau equal to r bar cross f bar. Similarly angular momentum also, it is multiplied between r and linear momentum vector product. Linear momentum vector product. So linear momentum, you know, that is m into v into distance, mvr sine theta. Okay, L equal to mvr sine theta. Here, so first of all we need to understand perpendicular distance that is there from the line, y equal to x plus 4. That means, so it will be, okay, y equal to x plus 4. What is the y equal to mx plus c, like that only it's there. So what is this line? So intercept will be, okay, 4 and slope is 1. Okay, so here perpendicular distance I am calculating. So that is equal to, so intercept by this one, coefficient of y square plus x square minus 1 square plus 1 square, for that modulus, that means 4 by root 2. So 4 by root 2. Now angular momentum is equal to, what is this, 5 into 3 root 2 into 4 by root 2. Root 2 root get cancelled. 15 fours, how much? 60. Okay, 60 kg meter square per second. Why we are taking? Because it is a perpendicular distance. Okay, here perpendicular distance, both two vectors are there. Okay, if you multiply again you will get another vector. This is a vector product. Okay, mvr sine theta. So it's vector product, that's why we got sine theta. If it is dot product, we will get cos theta. A dot b bar is equal to ab cos theta. Whereas here L r cross p bar. P is momentum, that is mv bar. Okay, mv bar. Okay, this one, r bar cross p bar. So P is mv bar. Okay, that is what. So here we got 60. So it is also simple, only you need to understand the concept why it is applying. So from which point we have to take, what is the equation. Okay, from all the things we need to understand. Next one. So next one is also a simple problem where we need to calculate the angle of angular momentum only. Here a particle of mass m is projected with velocity u, making an angle theta 30 degrees and with the horizontal, and u is the velocity. So magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height, that is h max. At this place we have to calculate. If you observe here, it is going like this and this is r. This is what? R. This is what? Radius. Means angular momentum L equal to mvr sine theta. Okay, here here what happened? U is which one? Here this one. So like this, it is horizontal, this is along vertical, that is y-axis, this is x-axis. So H max is vertical direction, whereas range, this one, range means along this direction. So that's why I am taking, this is what I told, L bar equal to R bar cross P bar. R bar is what? H max. R bar is what? H max. H max formula, U square sine square theta by 2z. Whereas momentum is, what is that? Mu cos theta, because it's x-axis. So that is mu cos theta. What is the angle that he has given? 30 degrees. So into this one actually. Okay, I'll erase. Okay, now if you observe mu cube by 2z, cos 30 is how much? Cos 30. Cos 30 is root 3 by 2. Whereas the sin 30 is 1 by 2. For that square is there. Now you will get 1 by 4. Now what is asking? He is keeping mu cube by g. Mu cube by g you keep as it is. That is root 3 by 2 2's 4. 4 4 16. So root 3 by 16 into mu cube by g, this is the answer. So here we need to understand how to calculate angular momentum. Angular momentum equal to radius into, or r into, that is position vector, it's not radius, it's position vector into the linear momentum. You have to multiply, you will get the angular momentum. Okay, this is the answer, simple one only. Okay, now another one. Here also, if you observe, disk is there. Initially, that is a mass of 5 kgs. Mass is 5 kgs. This is also one of the important model, 5 kg. Radius is 2 meters. Rotating with the angular velocity omega equal to 10 radian per second. In identical, gently over this one. So now what happened? Initially, here energy dissipated. Okay. L equal to I omega. L equal to what? I omega. Here, after that also, 2 disks are there. Now, what happened? Here, initial, there is no external force, that is external torque applied. So, that's why initial disk means, what is the I formula? I equal to mr square by 2. mr square by 2. Initial angular momentum, if you consider Li, final angular momentum after keeping another disk, if you consider, that is I omega final. Okay, I final omega final. I initial omega initial. So without applying anything, any external torque, initial angular momentum equal to final angular momentum. Here also initial kinetic energy, rotational kinetic energy of I1 omega 1 square, of I1 omega square. Li you can calculate, that is 5 into 2 square by 2 into omega is 10. Okay, cancelled. 2 to get cancelled. 5 to the 10, that is 100. What is the answer? Kg meter square per second. Okay, that's it. Now again, kinetic energy Ki. You need to understand kinetic energy dissipated so that both disks continue to rotate without slipping. Here also calculate of I 5 to the 10. 10 into 10 square. That is a 500. 500. What is the energy? Joules. Okay. Initial momentum equal to final momentum. Initial momentum, that is Li equal to Lf is equal to 100 into, now how many disks are there? 2 disks are there. That's why 2 into mr square by 2, that is 2 into 10. Mr square by 2 is 10. Omega final. Okay, 2 5 is 100. Omega final equal to 5 radians per second. So now E final is equal to half I2 omega 2 square. Here I2 is how much? I2 is 2I. 2 into 10 into 5 square. Okay, 2 to get cancelled. What is the answer? 50. 5 square is 25. 25 into 10, 250 joules. Energy dissipated is equal to 500 minus 500 minus 250. That is 250 joules. This is the answer. So by keeping another disk, we are losing 250 joules. So that is energy dissipated. Initially there was 500 joules. If you only one disk is rotating with the angular speed of angular velocity of 10 radian per second with a radius of 2 meters and mass of 5 kg. Another mass of same identical mass if you are keeping. So we are losing the energy, that is 250 joules. This is simple bit only without slipping. So we are losing 250 joules. Now another one. Here also we have two disks of moment of inertia about their central axis and normal to their planes rotating with the angular speed of 10 radians per second, 4 radians per second respectively are brought into contact face to face with axis of rotation coincident. So initially they are separately doing. Now what happened? Without applying any external force, we are just contacting them. That's why initial angular momentum is equal to final angular momentum. So initial angular momentum 4 into 10 plus 2 into 4 is equal to 4 plus 2 into omega naught. Okay, 40 plus 8, 48 by 6, right? 4 to 10, 4 into 10. 2 into 4, 8. This is what? 8. This is what? 40. 40 plus 8, 48 by 6. So that is 8. Okay. So is equal to omega naught. Omega naught equal to 8 radians per second. So this is the thing. Now what we have to go? Again, loss in kinetic energy of the system in this process. So initial kinetic energy E1 is equal to half I omega 1 square plus half I2 omega 2 square. Here half I1 is what? 4 into omega 1 is 10 square plus half into 2 into 4 square. So cancelled this one. 2 into 10 square is 100. 200 plus 2 to get cancelled 16. That is 216 joules. E2 is equal to half into I1 plus I2 omega naught square. I1 plus I2. 4 plus 2 is 6. So 1 by 2 into 6. Directly I am writing. Omega naught we got 8. 8 square. 8 square is 64 into 3. 64 into 3. That is how much? Okay. So 12. 192 joules. So how much energy dissipated? 216. Loss is equal to 216 minus 192. 16 plus 8 how much? 24 joules. This is the loss. Because of keeping both in the contact with each other, so we are losing 24 joules. This is also simple bit. Again another one, same type of thing. A body of mass m is projected with a speed u making an angle 45 degrees with horizontal. So horizontal means ground. So angular momentum of the body about the point of projection at the highest point. So already we have done similar type of problem. That is at highest point, what is the angular momentum we have to calculate. Again L equal to mvr sin theta. Here r is the position vector. So L equal to mu cos theta is a linear momentum into h max is u square sin square theta by 2g. Okay. Again you can take mu cube by g outside. Cos 45 is 1 by root 2 into sin 45. 2 root 2 I am writing because 2 is there. Sin 45 is 1 by root 2. For that root is there. So what you will get? Okay. Now mu cube by g into 1 by 4 root 2. But root 2 is there in the top. So mu cube by g into 1 by 4 root 2 is equal to root 2 mu cube by xg. Okay. Mu cube by g you can cancel. So x is equal to 4 root 2 into root 2. That is 8. X is equal to how much? 8. Then you will get 4 root 2 in the bottom. So simply you can calculate, nothing is there. So easily you can calculate and get the 4 marks. Then, so I'll write here. So I completed this problem. Like this, if you write one side linear, another side if you write angular, like this, and compare the things. So this is what I teach to students generally while dealing with the classes. Linear displacement, if you write, that is S. Angular displacement is theta. Whereas linear velocity, that is V. Angular velocity is omega. Linear velocity acceleration is A. Angular acceleration is alpha. Now you write the relationship. In a circle, if you write like this, so this is the distance S. This is theta, this is R. So how will write? S equal to R theta. How you got the velocity? That is rate of change of displacement. That means V, if you do differentiation for S, you will get V. R omega. Similarly, if you do differentiation for that, A is equal to R alpha. Alpha equal to d omega by dt. Omega equal to d theta by dt. Similarly, V equal to ds by dt. A equal to dv by dt. Then F equal to ma. F equal to ma. Here tau equal to I alpha. Here m you write. Here I you write. Here linear momentum P is equal to m into v. Here angular momentum L equal to I into omega mv. Okay. This another relation tau equal to Rf. Okay, tau equal to Rf is equal to I alpha. Okay, F equal to ma here. Another thing, we can also write, what is it? Work is equal to F dot S. Here also work is equal to, in place of F you can write tau into theta. Okay. Another thing, power is equal to force into velocity. Here power is equal to tau into velocity omega. Similarly, kinetic energy is equal to half mv square. Here rotational kinetic energy is equal to half I omega square. Another thing, a linear impulse is equal to F dt. Here angular impulse is equal to tau dt. So like this, if you write and understand the relationship between these two, you can clearly understand. L equal to R bar cross P bar. Another one. Okay, these are the things. How I is also related. I equal to m r square r. Okay, r is a radius. Okay, simple. So these are the relationship. If you know this relationship and how to apply the formulas in each and everything, you can clearly get all the problems. Rotation motion is much easier. Okay, thank you. All the best.